So we're gonna finish the day with Thierry from the CNES, which is the National Center for Space Studies, and he's gonna talk to us to a space and robotic long-standing tradition in France. And please, Thierry, if you could walk here and take a microphone and facing people here and give a presentation of this National Center. Please, thank you.
Okay, so good morning, ladies and gentlemen. I'm very pleased to be here. So my name is Thierry CHAPUIS. I work at CNES, the French Space Agency, and I belong to the strategic department. And in this strategic department, I belong to the New Space Division. And my role is to promote the usage of space technology and data in the agriculture and forest sector. You may ask why CNES is here. What is the link between the CNES, Space Agency, and robots? Just a few words of CNES. So CNES is the French Space Agency, I would say the French NASA. And we are not as big as NASA, but we are about 2,400 people. And in Toulouse, you have the main technical center with 1,700 people. The headquarters are in Paris. We have the launch pad in Kourou, and also facilities in the suburb of Paris for launchers. The budget, which is the government budget, is important. You see, 2.6 billion of euros. I must say that one half of this budget is dedicated to the European Space Agency. All the big programs, scientific programs, launchers, INCs, maybe you've heard about INCs, are directly managed by the European Space Agency. So the budget comes from through CNES. And one point to mention is that regarding the effort made by France regarding space and regarding the amount of money per inhabitant, we are ranked second in the world. The first one are United States of America. And regarding also the ecosystem, you have 70,000 people working for the space activities, downstream or upstream activities. So the title is Space and Robots, a long-standing history. And when you see that, you understand that when you work for CNES, you have to deal with robots. A launcher is a robot. Everything is automatic. The only thing you can do is to destroy the launcher if the things are going wrong. So you don't want to push the red button. Considering the satellite, the majority of satellite, except geostationary, they orbit at the same speed as the Earth. So that means that you see these satellites on a continuous way. But for the other satellites, you don't see them very often, for example, for observation. That means, for example, you will have the contact with them 20 minutes a day. So that means that you have the satellite has to be autonomous. And for example, you have to download the program just to program the recording of the images. So it's a robot. And in the two other cases, the first one, you may recognize the Mars project. In that case, you must understand that the time it takes from a signal from the Earth to Mars is 20 minutes. So if you send the command to Mars, it will take 20 minutes. And if you want the answer, it will take also 20 minutes. That means 40 minutes to have the information. And considering, for example, this very, very critical phase, which is the landing of the robot on Mars, you have to be totally autonomous. So, you have to be sure that everything will go right, because if you have any problem, the robot will crash on the ground of Mars. And the last example is maybe you've heard also the FIRA probe, which was on a comet. And in that case, also you have the problem of distance. And here you have a communication between the probe and the satellite. You see the satellite in the picture orbiting around the comet, and then transmission with the ground system. But also in that case, you have the time of transmission of signals, so you have also to be autonomous. That means that regarding our methodology, we have to deal with reliability, with safety, and now in the field of agriculture, with all the safety problem you have also to implement this kind of methodology to be sure that the robot will not hurt anybody and will do the job as it is programmed. So now, just to explain the link between space technologies and data and agriculture. So general overview. So first you have Earth observation. And here you have the example of the Sentinel-2 satellite, which is an optical satellite, very useful for agriculture because the resolution is 10 meters, and you have a global coverage. So with that, you can do land cover, you can do crop monitoring, you can do yield prediction, or you can optimize your farming inputs. So you have already some tools which depend on these images, and these images are free because it's funded by the European community, and all the images coming from Sentinel satellite, 2 is optical, Sentinel-1 is radar, are totally free. For the second one, it's GNSS. So now it's no longer GPS. GPS was the first system, but you have now 4 systems: GPS, Galileo, the European one, GLONASS, Russian, and Beidou, the Chinese. And so if you consider agriculture, generally you will deal at the end with maps. You will deal with a geographic information system. So that means that you have to locate your information. So everything has to be located as accurate as possible. And you have also the necessity to date your information, because generally you want to have the history. And one important point of GNSS is that also you have the timing of the information. And it's a very precise timing, and it's the same timing all around the world. So this is a very efficient and very interesting service. And you can use also for data collection if you have some implication on your smartphone and tablet. And the last, guidance, because guidance is necessary for robots. And in case of robots, and I will have some slides about that, you have to be very accurate. Because, for example, if you want to weed a crop, you have to be very accurate. So in that case, the GNSS is the main sensor to guide your robot. And the last point is the communication. So now regarding I will say using numerical data in agriculture, you will have more and more in situ sensors. For example, meteorological station, you will measure the humidity of the soil, and you want to connect these sensors, which are in the fields, with your system. And generally, if you have a ground system, no problem, you can do it. But there were some cases where you have no ground system, and if you consider, for example, going to international, there are some countries where you will find very big problems to have the connectivity. So at CNES, we developed with CNES a constellation of 25 satellites. So the name of the constellation is CNES. And the objective of this constellation is to have a IoT, Internet of Things capability. And it will be operational next year, this year and next year. The first batch of satellite will be launched in June. So it's a very short time availability. So I will speak about the problem of performance measurements. So how you are sure that your robot is on the right trajectory. And we have some activities rather a long time ago. It was in 2016 with a GID laboratory, which is located here in Toulouse, and it's a laboratory specialized in GNSS and metrology. And we have a project in 2016 with NIO. Everybody knows NIO. And at that time, you see one of the first versions of OSE. And when we discussed with them, they didn't use at that time differential GNSS. So they have some problem with the rank with the U-turn. It was not enough precise to be sure that the robot can go through the ranks of planes. And so at that time at CNES, we developed a technology which is PPP, precise point positioning, and it was developed by CNES. And we tested it on the OSE robot. And we were rather happy with the results because you see the pictures. So the trajectory is very good. And we were also satisfied with the behavior of the robot under the greenhouse. It was a plastic greenhouse. So it was interesting to see where and NIO understood at that time, but probably differential solution should be necessary even for us, and it's now the case. So you have a problem of metrologies. So when you want to check the accuracy of a robot, the problem is to say, what is the reference trajectory? And it's not easy because if you want to be accurate at 2 or 3 centimeters, theoretically, your reference trajectory should be better. And also with GID, we work on that. And we work with agriculture. It was in 2019. I see some of them here. And we put on board their robot. Here you have example an IMU landed, so inertial measurement unit, just to have a better reference trajectory. And then we performed some tests. First, it was elementary test, and the second one, I would like to.
Please, to the techniques, there is a video. Can you peux la lancer? Pardon. Lancer la vidéo, ouais.
Si tu te mets dessus, tu vas pouvoir la cliquer. En bas, là. Tu mets en bas.
Sorry.
Technical.
That's all.
It's okay? Okay. So we made some operational tests, and it was filmed by a drone of agriculture. And it was interesting to see the repetitivity of the trajectory. So the system was on board their robot, and it was done in a field not far from Toulouse, in the beautiful country of Lauragais. And so you have really an idea of what is necessary for a robot and to be repetitive and to have the same trajectory, especially during the U-turn. Another project with agriculture. So more precisely, 2 projects. The first one is a NAVIST program. It's a European program. And CNES found the AGC, their box, AGC box, industrial development, some years ago. Now the contract is over. And we have also another contract in the frame of Plan de Relance. So it's a French also program. And this project was more related to the safety aspect. And the question was, if you want to be sure that your robot stay inside the working zone in any case, you have to be very confident about the location given by the GNSS. And when you speak about differential GNSS, you need some correction messages. It's necessary. If you have no correction messages, you have no accuracy. So the question is your messages correct? Do you have any problem with the reliability of your message? So that was the goal of the project. And this project was conducted in collaboration with Thierry, which is a company which is delivering correction message and precision message. This is different. I will also give an example of, you have a robot, and you could imagine that the robot could have a modulation map and do some modulation. So modulation, that means fertilizer, could be phytosanitary products. You can spray some products. And we had a project, it's not over, with Rémi Martin, which is a cognac producer. And the idea is to see are we able to have an idea of the vigor of the row. And if you see the picture, you see that you have grass between the rows. So if you want to really know the vigor, you have to be very, you have to have a very good resolution of the image. And in that case, we use the images from Pléiades Neo satellite, which is the last generation of Airbus Defence and Space satellite. And the resolution of this satellite is 30 centimeter black and white, chromatic, and 1 meter and 20 centimeters spectral bands. So we developed an algorithm to automatically detect the rows. So we detect the rows, and as we have detected the rows, we select the pixel belonging to the row to calculate a vigor indicator. So in that case, when you have white dots, that means that you have no plants or very low level of vegetation, and with the red or dark red dots, that means that you have a lot of vigor. So it can be used for fertilization, for spraying fungicide on the vineyard, and also it's a way to have an idea of the dead or missing plants, which is also a problem very important for the vineyard. So this is my last slide. So well, it's a joke. So what is the new market? So because I'm working in space, so I say maybe Mars. Maybe Mars. There are some project and some ideas to send men on Mars. Very difficult. And imagine that you have some men on Mars. You have to feed them. I suppose that many of you have seen the film Alone in Mars. And it's why I put some, it's my colleague, because I'm not able to do that, I put some Nio robots on the surface of Mars. One, the Dino, is dealing with salad. In the film, it was potatoes. But also, you see that maybe it's not the perfect place to perform agriculture, because you have only rocks. Thank you.
Merci beaucoup. Thank you very much, Thierry. That was the last talk. Is any question here? And Thierry, just what I guess is, in fact, National Center for Space Studies gave information since a while to the robotics agriculture market, but you developed also some projects, and I was wondering if aerospace technology gave a birth to agricultural robots. Is that the case or not? Or this is just like parallel project, and because these two worlds met each other, it become not a dream but a real world?
I think that you have to think about two points. First one, for example, GNSS is fundamental for the robots. And you can do it because you have constellation. And it's better to have 4 constellations instead of 1. So that means the emergence of Galileo constellation, which is a very performant constellation, is a good thing for the robot first. And then regarding also the performances of GNSS receivers, they are used by agriculture, but they are used also for geodesy, for scientific activities. So that means that all the algorithms, all the technologies which are available for the robots were developed before. So the link is that the space has given the technology and the possibility for the people developing robots to use this technology.
Okay. And what about university around Toulouse and all? Do you have a view of what's the next step except to being in Mars?
I think that considering the market, the safety is a real problem. So a problem. You have to tackle the safety problem. Because if you need to have somebody just near the robot to check the robot, there is an economical problem. So, and it's not easy to guarantee the safety. So this is the first point. The other point is economic also. This is the price of the robot. So that means also when you discuss with farmer, the question is I have to invest, but what is the return of invest? I think that it's very interesting. For the beginning, I think that robots have really a place in the agriculture domain, especially, for example, for weeding. Weeding is very interesting, and it's also very interesting regarding ecological aspect, because you don't need any herbicide when you want to do that. So it takes time, but it's not only the case of robots. It takes time to have the technology and to have this technology spread in the farming domain, the agriculture domain.
Thank you very much. It will be the last words. Thanks to, we can applaud again Thierry, and thanks to all. We were in the Earth of Agricultural Robots Project and needs, thanks to the FIRA 2004, and thanks of course to all speakers and also translators just behind us, facing us, sorry. And the show carry on outside because we've got still demonstrations. So thanks to all, and have a nice time in Toulouse, in Occitanie region, and in Sicoval. Bye.